Okay, welcome everyone. This is now session 14. At this point in time, students have completed their fix-ups from the recent peer checking. Now the next step, or the next thing to do, I guess, is look at or cover project or assessment submission. Now, now that the projects have been fixed up, I guess the final thing to do is do a reprint to PDF. What I'd like, so that's the final part of this project, is to actually do a print to PDF. The final set of prints is the one that will go up to Learn as the final submission, together with the Revit project file. Now, I will also talk about how to reduce the size of the Revit project file, because if it's bigger than 20 meg, it won't go up to Learn, because that's the limit for Learn itself. So we'll cover that shortly, but just before we do our final print, I just wanted to quickly cover line weights. Line weights with regard to architectural drafting. Now, what I'm sort of going to go through is not a comprehensive discussion on line weights as such, because I guess it's a much broader aspect of producing documentation. I just wanted to mainly sort of, within the program itself, sort of show you where you actually determine the line weights that are currently set, and I guess make some minor changes if required. Now the thing is that when it comes to line weights or line thicknesses, if you were to zoom into your floor plan, for instance, get in very close like this and actually turn on your thick lines up here, and you're probably obviously aware of this by now, that with thick lines turned on, you can see that some of the lines are thicker than others. So the the variation in thickness is, well, there is quite a bit of variation in thickness based on the object itself within the building. So I guess the question is, why are some lines thicker than others? And I guess to answer that initially, if we have a look at this graphic here, I guess the thinking behind this is that with your floor plan, the reason that we actually see the floor plan in its current form is that the building itself is cut through. And it's cut through at a height of 1200. Okay, so and that's a setting within the view itself. That's the cut plane. Okay, set at 1200. So here in this image here, this is the cut plane here at the top of these walls. That's the 1200.
That's your darker line.
That's your darker lines. So the thing is that if a building element is cut through, it's represented with thicker lines, as opposed to anything that's not cut through, which is said to be in elevation. So that line work is more or less all the same thickness. It's quite thinner than the objects that are cut. So you can see in plan view, you've got your thicker lines to represent your walls cut, and then of course here the window openings, albeit that there are no windows in them, are thinner lines or light solid. Now, when we thicken up lines to represent an object that is cut, the thickness of the line also depends on the view scale, and it also depends on what the object is made of. So if it happens to be, this is brick for instance, or masonry, the lines are much thicker than if we're actually cutting through a timber frame, for instance, or a stud wall. So there's variations on the thickness of the line work depending on the material. So, and I guess the thing is that how do you determine what the thickness of a line should be for something like masonry on the outside here, for instance, and timber on the inside? Now, I'm going back to, I guess, when I was using and teaching AutoCAD. We used to thicken up the lines of the masonry walls, so they were thicker than the line work of the timber walls inside, so given that this is brick veneer. And we talk about line thicknesses being 0.15, 0.18, 0.25, 0.35, 0.5 and 0.7. So I'll just take you back to the origins, I guess, of pens and line thicknesses. And it goes back to the days of manual drafting, which is still being done today, but not as much. And it comes back to these technical pens, which I've used when I did the course back in the mid-90s. I used these pens for manual drafting. The Rotring or Rotring brand was quite popular back then, and it still is. They're a very good quality pen. And I guess it may be a little bit hard to see, but each of these pens has a value on it which relates to a thickness. So 0.1, 0.13, 0.18, 0.25, 0.35, right up to 2 mil. Okay, so when we're talking about AutoCAD and Revit, we talk about pens, and this is where the pen comes from. So the thing is that with pens, and I guess when you are allocating line weights to objects, either in AutoCAD or Revit, you talk about allocating or assigning a pen to that particular object or layer. So, and it's best to perhaps restrict these individual line thicknesses to about 7, okay? So, 1, 2, 3, 4, 5, 6, 7. So we go from 0.1 to 0.7. So 0.1 would be pen 1. This was pen 2, pen 3, 4, 5, 6, 7. Okay, so we give them a number. So just bear that in mind. But this is essentially the origins of, I guess, drafting and line thicknesses. Now, when you are manually drafting, of course, you need to obviously select the correct pen for the particular line you're about to draw based on the thickness that it should be. So you have to be very clear on what pen to use where in the drawing itself. But knowing what pen to use just comes with experience. So for instance, I was saying earlier that for masonry walls at 1 to 100, we use 0.35, a pen which is 0.35. For timber walls at 1 to 100, we might use a 0.25. Okay, any sort of hatching work, we actually do very, very fine at 0.1. Okay, so when it comes time to do the hatching, if you're doing it manually, you take your 0.1 pen and use that for your hatching. So that's manual drafting. We then sort of have a look at AutoCAD itself. Now, AutoCAD, for those that have used AutoCAD, you'll note that AutoCAD, you draw in colour and you draw on layers. Okay, so if you were going to draw your masonry walls in AutoCAD, you would actually draw them on a yellow layer, and the lines themselves would be yellow, knowing that yellow, when it's printed, will print 0.35. Okay, colour 7 might be 0.25. So it just depends on how you actually sort of what you nominate the colour to be in AutoCAD itself. So you actually allocate a thickness to a colour in AutoCAD, and that's the way it works through something called plot styles. Now, I'm not going to go through and sort of just talk about AutoCAD. AutoCAD is a different system, but it's a similar or shared concept. So AutoCAD just uses coloured lines to represent line thicknesses. Now, when we come back to Revit itself, the question is, how do we control or change line weights? And how thick are these lines currently? Because out of the box, essentially with Revit, someone has gone through and actually assigned line weights to every aspect of Revit itself, both 3D objects, you know, walls, doors and windows, and also line work as well, sort of detail line work. Now the thing is that if we go to manage and additional settings, if we have a look at line weights here, so here is where we initially sort of discover or find out what the line weight settings are. If you are going to make changes to your line weights in your project, it's a good idea to actually perhaps print this out and have it sort of sitting next to you so you can refer to it, so you know what the current settings are. So you can see here, down along the left-hand side, you've got 1 through 16. So again, these are what I refer to as pens. Okay. Now again, I said earlier that restrict yourself to maybe 7 pens only when you're actually assigning line weights. And knowing that pen 1 is the thinnest, and as you go higher in number, you go thicker. So if we're talking 1 to 100, which is the scale of the floor plan, you can see that pen 1 is 0.1, pen 2 0.18, and then we go to pen 7, which is 1 millimetre. So the line that you're seeing here, in fact, and we'll confirm this later, is either pen 3 or pen 4. Okay, it's either 0.25 or 0.35. Now the thing is that ideally with with your walls here, you'd want the thick line that's showing here, you'd want it actually here on the other side of this brick wall. Either side of the timber wall, you'd want a slightly thinner line, okay, because again timber is we represent timber with a thinner line than brick itself. Unfortunately, with the way Revit is set up with its walls, this is all you have. Thick on the outside and thin on the inside, and the two cavity lines here are the same thickness. Okay. The result is that this thick line is actually carried through inside to the internal walls, so they tend to be too thick. There is a way around that, but it's quite manual, and I can sort of show you quickly how we do it, but it is a little bit time consuming. Okay, so so 3 and 4, 0.25, 0.25, 0.35. Okay, we'll close that. So that's the table that gives us our pens and our relative thicknesses based on scale. Now, to find out what these actually are, we go to Object Styles here, which is on the Manage tab again. And Object Styles in Revit is your master control center for display. Okay. So whatever you change in Object Styles is going to change those particular objects for the entire project. So this is not per view. This is per project. So if we're talking about line weights, which is one aspect of Object Styles, that's sort of controlled here. You can also set your line color and also your line pattern and the material assigned to objects here as well. So if I expand this out further, perhaps I'll push it up so we can see it. If you scroll down to the walls category, expand walls, you'll see that on the right hand side here you've got cut, on the left you've got projection. So we're talking about cut, these are cut. So walls, we've got pen 4. Now pen 4, going back to our line weights table, was 0.35. So for me that's just a little bit too thick, and it's mainly, it's probably okay here, but it's too thick for this. Too thick for the internal walls.
So do you bring it down to 3?
Yeah, so if we reduce that to pen 3, we know that these walls are going to drop back to 0.25. And if you leave Object Styles open and click Apply, you'll see the change in the background. See how they back off? They're thinner. Now, I'll just move that to the side. Now, if we're talking about things like window components, so if you can appreciate that all of your line weights are controlled in Object Styles, and all of the line weights are controlled by object. So whereas programs like AutoCAD, line weights are controlled by layers, Revit, we control line weights by categories, by objects. So we go, we've just changed an aspect of the walls category, which obviously affects the walls itself. Now, so again, this is based on scale. So if we're going to, for instance, change, if we want to make the line work within a window a little bit thinner, for instance, or thicker, we can do that as well. We go down to the windows category, and I guess the thing is that you get an appreciation of the enormity and the complexity of this process. Look at all of the subcategories underneath windows.
Huge.
All the things that you can potentially change for a window object.
They're all nested objects, aren't they?
Yeah, they're subcategories. So if you were working in a architectural or design office as the BIM manager, and you had to set up a template for your team to use, one of the things that you would do, one of the main things you would do, is go through and actually set up all the line weights for all aspects of the project. And it's a task that can take months. It's just huge. And it's one of those things that you may sort of, it just may be a work in progress.
So once you've done that template up, and once you've changed it, it's set then until you rechange it. Is that
right? Correct. Yeah. So the idea is to set this up in a template, go through and make all the changes, and then every time someone starts a new project, they use the company template, and all the line weights set. So the individual drafter doesn't have to go through and make changes on the fly.
So that's the company's responsibility?
Yeah, so it becomes a company standard. Yeah, it's the company's responsibility.
Signature custom.
Yeah.
You were saying it takes months to set this up if you were to go through and change everything or make sure that everything's the same. So if for some reason you had to do this for every single project would take months longer.
No, I'm saying months. I'm sort of saying months. I really mean it's a big task, and I guess time-wise, depending on the complexity of the projects that you're undertaking, the time it takes is proportional. It's a big job. But the thing is that if you actually do this inside a single template, then you only do it once. Okay, you would only want to do it once. You wouldn't want to do it a second and third time. It's just such a big.
The other thing is you'd just be having huge amounts of sort of disagreement between senior architects about what sizes they wanted for their weights for every.
Yeah, and that's the thing. Within your drafting team, you might have someone say, "Oh, listen, I don't agree with you with that line weight. I don't like the line weights in that view. Can we change that?" And yeah, it becomes a consultation thing. So a work in progress, but it's just one aspect of setting up a template, but it's a huge aspect, and it's a very important aspect. Because at the end of the day, when you print your drawings out, they need to be readable, and they need to visually they need to be crisp and look professional. And it's a very hard thing to do, but it just comes with experience. I guess when you sort of get onto and do your working drawing subjects in the future here at TAFE, and you're doing more comprehensive working drawings, you will have to consider this a lot more than you currently are. The good thing with Revit is that some attempt has been made already to set line weights in the starting template. They're not bad, but it's a starting point. There's obviously a lot of room for improvement. Whereas with programs like AutoCAD, there's absolutely nothing. You start a new drawing in AutoCAD from their base template, and you've got nothing. At least with Revit, you've got somewhere to start. So yeah, so that's essentially, I guess, a little bit about line weights, I guess a bit of background on line weights themselves, and how you actually find out what they are and how you can actually change them within a project.
That's actually interesting because I was looking at mine and thinking it's a bit thick and chunky, and that with moving that point down by 1, it may not come out that way.
No, it just helps it a little bit. The other thing that you can do, as I was saying earlier, if you wanted to actually sort of reduce the size of the internal walls, for instance, their thickness, you can do this, which is modify, and you can use this tool here called line work, which we have had a look at before. And what line work allows you to do is to override on a line-by-line basis, override the thickness of an existing line in a view. So line work, in the list here of line styles, so we're talking about solid lines. You've got lines, medium, wide and thin. So if you click thin, for instance, and then click on an existing line, see how it changes it? Changes it instantly. It overrides the default by category setting, which is set in object styles.
So we could go on
I wouldn't suggest that you do it for this project because it is quite time consuming. If we go to medium lines, that to me is a better line thickness than this one here. It's just a little bit thinner. So it's probably more appropriate for, and you could actually, click, see how that works? And you could actually, you could then click this line here, which is the cavity line, and get those two lines the same thickness, which is more along the lines of what I'm used to with programs like AutoCAD and also manual drafting, okay, where the two timber lines are thicker or thick, but they're not as thick as the two lines that denote the masonry walls. I can make the masonry walls, this one, wider by going to a wide line, but it may be a different thickness to this one here, which it is, okay? So it gets a little bit messy. But I'm suggesting that you don't make these changes to the current project. I suggest that you just leave it the way it is.
Can we do
now,
three for the walls just because it looks so much better?
Yeah, the thing is, if you're going to sort of override all the line work in the floor plan, it's going to take you quite a bit of time, and we just don't have that time to do it.
I'm just thinking about with the object style.
Yeah.
Just do the object style of that 3-point thing.
Yeah. If you have made changes through the line work tool, this one here, where are we?
I have made those changes. No, I don't want to touch those.
Yeah, if you want to reverse those changes, it's quite simple. You actually use the line work tool, and in the line style list here, you go up to by category, and by category just means that the line thickness is now returned to the line thickness that is set in object styles. Okay, so that's the master control. So that was 0.25. Pen 3.
Just removes the override.
Yes, correct. Yeah. So, and we just go back to what it was originally. Okay.
my internal wall didn't go back for some reason.
If you use the by category, it should, using the line work tool. So
I clicked on the wall then.
yeah. So the line work tool is good in the sense that it's okay for some very minor tweaking of views, and particularly views like detail views. Okay. Again, I wouldn't suggest using it in a broader sense. it's best to try and sort of come to a happy medium with your line weights through object styles. So, for instance, with your walls here, okay, if we go back to manage and object styles, the cavity lines through here, again, are controlled within the walls category, and then they're known as common edges here. And they're currently set to pen 1, which is the thinnest pen, which is 0.1. So if we were to actually change those to pen 3, for instance,
And that throws out, that blackens out the
walls, common edges.
and the walls themselves we changed to 3, didn't we? The walls.
changed to 3.
So now they're all the same thickness.
Except that what you got is then your new wall has actually done something different. Like your new wall's all very dark and grim. So
Yeah, that's right. I mean, yeah, what we do here has an impact on all walls, and you'll see that, you know, when you go too thick with your wall lines, they sort of merge into one another and just become a huge, big, thick line, which is not ideal. So you just have to sort of be careful in that respect. So I'll just, sorry, walls. Just back them off. So common edges, we take that back to 1, which is much better. We've backed off walls in general to pen 3, which is 0.25. So for display purposes or for printing, that's a little bit better than it was before.
So we should have common edges at 1 and walls at 3.
Yeah, common edges, leave that at 1, which it was, and walls at 3. Okay. Now, if you were going to, say, adjust your windows, so your window frames, you would perhaps go down to the Windows category, Windows, and you would adjust your frame/mullion over here. If you are attempting to change a part of your model in terms of line thickness, and you're changing your pens over here, but there's no change happens in the view, and you're not sure what's going on, a technique that I use to identify the different parts of a window or a door, for instance, given that there are so many subcategories, is to actually go over and actually change the colour to something that's quite obvious and see what part of that object does change.
Okay, so we're going.
Not that I want you to change the colour of windows, for instance, but changing the colour will highlight that part of the object, so you can see, you can determine if you're on the right track.
Yep.
So again, if I wanted to, you know, back off the line thicknesses in here, now, and again, just bearing in mind that the display line thicknesses here are not necessarily how it's going to print. Okay, so there might again be a slight variation when it does actually go to printer or print to PDF. So it's just a rough indication of what the thicknesses are relative to one another. So if I change this, say, to pen 1 and click apply, you'll see that does, obviously they're now 0.1, so you can see the detail in there. I'll change that back to black. But this is a way of introducing colour into a view if you want a bit of colour, okay? If you're going to print in colour. So sometimes it is quite good to have just a little bit of colour, not too much. So that's where it's done here. So
It's
back.
like with the windows in some of our views.
Yeah, some of the windows that you've used it, some of the window families actually have blue lines in them that represent the glass itself. Now, I don't agree with that. I think they should all be black. We don't ordinarily print floor plans in colour. Okay, there are some views where a little bit of colour is quite nice, but generally it's all black. But the blue lines you get in the windows, that colour is generally set within the family itself. So you'd have to modify the family to get rid of the blue colour. Okay, so that's a little bit about line weights. Sorry, I'll just change these back to black. It's odd that they changed and not these ones. Or that one. Okay. Now, the other thing that I'd like to do that relates to line weights or line thickness is if you can open up one of your elevations, and just leave your thick lines turned on. So in the east elevation here, for instance, I can see the thickened ground line.
So is this in sheets or just in the?
No, this is the actual east elevation. What I'd like to do here, or show you how to do, is actually thicken up the line work in the elevations to make them stand out a bit more, okay? Because when they print, they're all going to be the same line thickness. And I guess the thing is that they're all the same line thickness because in elevations, for instance, the line work is said to be in elevation, which means that all lines are the same thickness. There's no variation, so nothing is cut. But we can enhance the elevations by thickening up the outlines. And the outlines of the elevations are known as silhouettes. So to make the change to the elevations, through the properties of this elevation, we actually go to Identity Data and View Template and click Elevations, the button here. So this is the template assigned to the current view, and it's the template that's assigned to all 4 elevations. So we go into Assign View Template. We're now modifying this particular template, this one here, and we're going to do it through Model Display over here and across to Edit. Now, this opens up graphic display options, and as I said, the setting we're going to change is one called Silhouettes. And next to Silhouettes, where it says None, you can actually assign an existing line style. Now, to show you how this works, we're not going to, but if I choose Roof Lines Demo and click Apply, see what happens? Yeah, see what's changed. Okay, so that's what's known as a silhouette. It's just the outline of the elevation itself.
So we just want to make it thicker though, don't we?
we just want to make it thicker.
So,
So we're actually going to go for a 0.25 pen. A 0.35 is going to be a little bit too thick. Okay, but a 0.25 is just a little bit thinner, but it just gives the elevations a bit of oomph, a bit of pop.
Weight behind them.
Sorry,
Just a bit of weight behind them.
a bit of weight. Yes, exactly.
They don't look like a sketch so much now, they look more like a picture.
Yeah, it makes them present a lot nicer, or on the sheet itself.
Did you just click OK?
Yeah, just click OK on that one. Now the thing is that that will carry through for all elevations. So just check your other 3 elevations to make sure that those silhouettes have come through.
I know it is. I didn't press the line.
If the silhouetting is not coming through to the other elevations, it means that you may not have the elevations view template assigned to the views themselves. So to correct that, you'd have to make sure that the elevations template is assigned to all elevation views.
Okay.
So just check under identity data next to view template to make sure the elevations template is assigned.
Well, that's interesting, because I've got one where it is assigned.
So under where?
Here, identity data, view template and elevations. So for all 4 elevations, if you just click, just go through them, so you should see that template
On all 4?
on all 4.
Okay, hang
This
on.
is interesting, because south, it is assigned, and it's not doing its job.
Okay.
Oh, hang on, no, you know what it is, I have to turn
I
it
think
down.
that it is assigning, because it just sometimes it's for whatever reason it chooses to do it
Darker.
silhouette differently.
Roll your finger in, roll it in.
Yeah,
It's just something to do
yeah. The
with
thing is that if you zoom in and out, it may look a little bit. It just depends on the zoom, but you can quite clearly see the silhouettes there. Yeah. So just something to check to make sure your template is assigned to all views.
Now I can.
So the benefit here is that when you make a change to the template, it updates all 4 views at the same time.
Can you just go to your south and let me have a little look at that?
Okay.
Now, once that change has been made, now that we've changed the floor plan wall lines, they're the only changes that I'd like you to make. You can make other changes if you want to, but at this point, if you're happy enough that you've had your project checked, you've fixed up all of the I guess issues that were highlighted, you've made the changes now to the line weights. The next step now is to actually do a final set of prints to PDF. So again, combine all 9 sheets into one PDF as we did in a previous session. So that becomes your final set, and that becomes the set that you upload to Learn together with your Revit file. And when I say your Revit file, it needs to be your main working file, not a backup. Now, having said that, as I said earlier, if your Revit file is over 20 meg in size, it may not go up to Learn. So I'll actually take you through a process now where we reduce the file size to prepare for that scenario. So you can do your printing now, and then we'll do the file reduction after that. All right, now just to prepare the Revit file for upload to Learn, we need to reduce its file size. So to do that, I'll get you to close any inactive views and close the project file. You can leave Revit open, just minimise it for the moment. Now, just if you just come back to the location of the Revit file itself, so if you do have any backup files, probably now is a good time to remove them and just leave yourself with the primary file. So you've now produced your final set of PDF prints, your sheets. So that's in this folder here as a single PDF. Now, when with the reduction of file size, you can see that the current file itself is, in my case, just over 20 meg. Okay, 20.8 kilobytes. So what we do is we right mouse on the primary file and we select copy, and then right mouse here and choose paste. So essentially we're making a copy of the primary file, which will have the word copy in it. And it's the copy, it's the copy itself that we now open up in Revit.
So just once we've selected it, we copy it, press copy.
Yeah, so right mouse and choose copy, and then right mouse down here and choose paste. And it produces a copy. So if you come back to Revit, and just open the copy now. Okay, so it's important that you do choose the copy and not the main file. Okay, just confirm up the top here that it does say copy. So from here what we're going to do is actually sort of purge or eliminate all of the objects that are not currently in use in the project itself. It's not something that I would suggest that you do ordinarily, because it is quite a drastic thing to do, because there may be objects or aspects of the project that are not in use that you may need to use in the future if you come back to this project, but if you actually purge them or eliminate them, they're gone for good, unless you reload them as families. Okay, we're only doing this essentially to get the file size down so that it can go up to learn. Okay, and that's why we purge. So we're just purging is just getting rid of things that we don't need. And if you're working on a project and you're loading in lots and lots of families and the file size is growing, at the end of the project, it's a good idea to sort of purge some aspects or some items of it, but not everything. So one of the things you can sort of get rid of is families that you're not going to use to get the file size back to a reasonable level. So if you are going to purge objects, you do it from the Manage tab, Purge Unused. Now, in the Purge Unused dialog, you'll see that here we've got listed views, families, and further down we've got groups, other styles, and so forth. So essentially, and if you sort of open up one of these categories, for instance, such as doors, you'll see that potentially the only door family you could purge or is this one here with the types underneath. Okay, so anything that's ticked will be purged. Same with walls, for instance. Any walls that are not in use can potentially be removed from the project itself. Any family or item that is currently in use will not be listed in the purge list. If you are going to purge individual items, the safest thing to do is actually click check none. Go into the category, the area you want to purge, and then just individually tick objects like that. So as you tick an object, you'll see the number of items checked increases down here. Not that we're actually going to purge everything in this particular copy, but if I was to click OK now, that would exit the dialog and remove these 11 objects. Now we're going to actually check everything again. We're going to check all. When we click check all, it then increases the number of items down here to 374. So these are the items that are going to be removed from the project. So if you were to open up this purge unused dialog and then click OK, it will actually potentially remove the majority of those objects without any warning. So it's a little bit dangerous in that respect. Okay, we're okay because we're doing it in a controlled way through a copy. So if you click OK, that's fine. If we then go back, now I know for a fact that it hasn't purged all of that 374. It'll probably leave about 60. So if we go back in and have another look, you'll see there are 60 items left. Okay, so you'll see that the list is reduced significantly. Okay, if we click OK again, it's going to purge more of these objects, but not everything. And we have to essentially do it 3 times. Now on this final OK, it will actually come back to 0. And I'll go back into the dialog just to verify that. So it's back to 0 now. Okay, so that's removed the objects. In removing the objects, it doesn't automatically reduce the file size. The file size won't even reduce if we actually do a save now and close the project. What we have to do is we have to do a file save as project, and we have to give this current project an entirely different name or a different name. Okay, so it's currently has the word copy in it. We're going to save it as a project, but we're going to replace the word copy with the word purged. And it's only by renaming the file that forces Revit or the program to actually compress the file and remove the free space that was created by the removal of those objects. So it compresses the file and brings it down to something like about 16 meg. So click save on that. Okay, so it now has the word purged in it. Now it's this particular version or file that will be uploaded to Learn. Okay, I'm happy with the fact that it has the word purged in it. I don't have a problem with that, but this is the one that goes up. So we close the project. We can leave Revit open if you want to, or just minimise it.
How do you close the project and leave it open? Does it seem to, oh no, it does, yeah, that's fine, yeah.
close all your inactive windows and then just close the last window or last view. As long as it's saved, it will actually close the Revit file, but keep Revit open. Now, have a look at the difference here. So the original file was just over 20 meg. The purged version is now 16.5. So it's reduced it by about 4 meg. The copy, the original, this copy here, we don't need. We can actually select that and delete it. So that just leaves us with the purged version and the original. Okay, so it'll be the this purged Revit file and the single PDF that now goes up to Learn. So here we've got project submission.
Mine's actually a few kilobytes out, which suggests there is some divergence in my thing.
Toilet was actually busy before I couldn't go, so.
Okay, so we get to project submission. So again, just to be quite clear, 2 files need to go up to Learn. They are the Revit file and the PDF, the single PDF, which contains the 9 individual sheets. So those 2 files go up, which form the assessment itself, or comprise the assessment. Now, in today's session, we haven't had time to, if I go back to the program, we haven't had time to cover creating a template for future projects. Okay, so this is our final session. We haven't had time to do that. It is quite useful and quite interesting to see how it's done. If students want to go through this, I did go through this in my night class, step by step. So if you want to go through this process, and it is useful and important that you do go through this process, because the template that you generate from the current project will be used next year potentially for your working drawing subjects. Okay, so it's something that you will have to do. Unfortunately, we don't have time today, but as I say, this is covered in my recording from my night class, the semester class here. It's actually covered along with a lot of the material we covered in today's session. It's covered in session 14 from my night class, this one here. Okay?
14 from your night class.
So session 14 of my night class goes through the creation of the template. Okay, so yeah, that will need to be done at some stage before you undertake the working drawing subject, and it may be next year, it may be the year after. Potentially it could be semester 1 or semester 2 next year. If you're doing full-time, and it can also be used, I think, if you're doing certificate 4, if you're doing the planning and building approval subjects in semester 1 next year. Okay, but it is a useful little exercise.
That's the semester,
Yeah, working drawings, for full-time diploma students, working drawings I think is timetabled for semester 2 next year. It can be undertaken in semester 1, so you can either do working drawings in semester 2 next year and design in semester 1. They're quite big subjects, or you can do them the other way around. But the template that you generate from this recording here will be used in the working drawing subject at some point in time. Okay, So, as I say, this is our final final session, final recording for the term students. So that's it. I wish them all the best, and we'll see them next year.
Yeah,
All right.
lucky, aren't you?
Yeah.
You'll see us next year.
Yeah,
Yes.
downstairs, and
Thanks, Russell.
you're going to have
Thanks.
to ask me to resubmit because I've just put one in with something wrong in it.
Okay. All right. Thanks, everyone.
Thanks.
Thanks,
Well,
Russell.
signing off.
Are you ready?